Hey, folks. Well, earlier on, we talked about software life cycles and different models for the steps that a software product might go through from the moment somebody gets an idea to the moment it's actually out there and in use. One of the things we talked about was design and this idea of taking our problem and dividing it up into smaller problems and thinking about the data structures that we would use and that kind of an idea. So I wanted to get into that in a little bit more detail here. I want to talk about different ideas for decomposition, and I want to talk about the idea of abstraction, taking a more complex component and deciding from an external perspective, what does this provide, what does this do, and sort of hiding a lot of the gory implementation details that we don't need to think about at any specific point in time. So I'm going to talk about top-down design, which you've probably already seen in your first programming course, the idea of modularity and the idea of abstraction, and thinking of this from a design and decomposition point of view. So again, one key focus of our design is decomposing the big problem into smaller problems that we can solve independently, and then somehow take these smaller solutions and lump them together to create the overall solution. And this allows the developer to focus on one part of the problem at a time, right? I'll go off and if I've taken my big problem and decomposed it into three smaller problems, I can go off and focus on one of the smaller sub problems and ignore everything else for a time being. And then I can go off and look at the second sub problem by itself for a while, ignoring everything else. And the same thing for the third sub problem. And then at a higher level, I can say, okay, well, how do I need to connect these three sub-problems together without worrying about the gory details of what's happening inside them, how the individual solutions were developed for those. I just think about how the problems themselves fit together. So this is the idea that we can focus on one part, abstracting away the details of the other parts while we're focusing on this one. And it does allow you to focus your concentration more, right? You've got a smaller set of details to worry about. And it also allows you to break a problem up amongst team members or amongst different teams better, right? You can give each sub-problem to a different person or to a different team, and they don't have to worry about, how your portion of the project works. They just have to focus on their own. And as long as we've decomposed this well, as long as we've thought about how the pieces will fit together in the long run, everything should work out happily. So when you're implementing kind of one of these higher level components, you think of, and from an abstract perspective, what are the lower level components providing for me, right? What do I absolutely need to know about them, and what things can I completely ignore? What gory internal details do I not need to know about while I'm trying to fit the pieces together? And then when I'm focusing on building one of those lower level components, when I'm building one of the sub-problems, again, I don't need to worry about how it's being used in the long run. I just have to think about, okay, well, I have to implement it so it provides feature X or service X or data type X. And as long as I provide that, I don't care how somebody else is going to use it. So this idea of abstraction as a way of modeling things in a way that provides just enough detail to work with the immediate problem. So we've got abstraction of control, where we've got processes or operations or sequences that we need to carry out. So we're going to abstract away, functions or methods. What is this function supposed to provide us with? If I don't need to know how the function is actually coded, what do I need to know if I wanted to call a function, for instance? If I wanted to include a library and call a function, what do I need to know about it? Right? I don't need to know what actual algorithm somebody used to implement a square root function. I just need to know how to call it and what it's going to give me back. Right? So usually this idea with control abstraction is we've got a name for the operation, again, function, whatever the function name is or method name is, and what kind of values it's taking in, and what kind of an effect it has for us, right? The externally observable effects. What does it do for me? How do I use it? What does it do for me? I don't care about its internal details. Right? So it's got to specify what kind of parameters it's going to take. any input it's going to get from the user, any kind of output it's going to produce, any kind of return value it's going to give you back, but the details of how it achieves that can be hidden. And then a similar idea with data abstraction, if we've got structs or classes or whatever it might be, from an abstract point of view, I just want to know, okay, this thing represents a circle. It's got stuff inside it that holds, the coordinates of the center and the radius. Now, whatever the data fields might be, we're thinking about it from an abstract point of view. What does this provide me with in terms of information, in terms of data, and not worrying about gory details of specifically how this thing winds up getting implemented, right? Just the publicly visible portions of this thing. And as we get into classes and more advanced data types, we'll start thinking about a data type in terms of both the information that it stores and the operations on that information that it provides to us. But again, we're going to be thinking of this from a sort of an abstract point of view. What's this doing for me? I don't care how you built it and how you got it to work. How do I use it? That's really all I'm interested in. And then the flip side, for the person who's actually building it, they don't care how you're going to use it. They just care about the fact that, okay, well, I'm supposed to provide a data type with these operations and, this data. And so I'll go do that. And I don't care who uses it or how. Right? So this abstraction idea, we only have to focus on one part of the problem, not the whole greater picture at once. So top-down decomposition, hopefully this is something that you've seen in your first programming courses. So far, we've probably focused on it from the point of view of sort of functions, where we're saying, okay, if I've got this big problem that, I'm going to have a main routine that starts everything off, and I'm going to think of this in terms of, well, there's this first big thing that has to happen, and a second big thing that has to happen, and a third big thing that has to happen, and so I'll write a function for each of them, and then I'll worry about the details of the first big thing in that first, when I go off to implement that first function, and I'll worry about the details of that second big thing when I have to implement that second function. Right? For the time being, I can just think of my main routine calling these three functions. Maybe I sit down and figure out what the profiles are going to look like. What am I going to call out? What kind of parameters will it take? What kind of return value will it give? But I'm really just thinking of it at the sort of observable effect level. And then as we get into those, implementing those functions, we'll go through and say, okay, well, this function still got a whole lot of stuff to do. Can I break that down into smaller pieces and have it call 3 or 4 other functions? And then, decide which details will be taken care of in those and go off and build those later. So we've had this sort of top-down design idea from the point of view or perspective of functions, but we can think of the same idea for a much larger system where we're saying, I'm going to have this big complex product and I'm going to break it up into several major components. Again, maybe a payroll system, an inventory system, a factory control system. But again, this notion that we're going to break the overall problem up into subproblems, and we're going to decide what's handled by each of those portions of our overall system. So each subsystem that we create, or each module in a subsystem, is going to have its own specific responsibilities, and it might be composed of a whole slew of different functions and different data structures or classes, whatever it might be. We've got this decomposition idea where we take the big problem, break it up into smaller ones, break those into smaller ones, break those into smaller ones, going as far down the chain as we need to until we get to the point where we can implement those final components fairly simply. Now, again, I think this is pretty much saying what I just babbled through in terms of, we've thought about it in terms of division into functions so far, but now we're more interested in taking a larger program and dividing it up into subsystems that handle a variety of different actions, that variety of different features. Now, the terminology here is going to vary from person to person, from group to group, from organization to organization. But the idea is we're starting with a big overall system, and we're dividing it up into smaller pieces and dividing those up into smaller pieces What names you give the pieces at the different levels is kind of arbitrary, but a fairly common one that you'll run across is the idea of system describing the product as a whole, subsystems being the kind of the key major components of that overall system, a set of modules making up any one subsystem, right? So you can get this sort of hierarchy of breaking down into smaller and smaller pieces. Again, the terminology, you can call these different layers whatever you like, but this is not an unusual one. Now, one of the big tricks is taking that first big problem and deciding how we're going to decompose it. What kind of pieces should I break this into that's going to make sense? So we want to think about a whole slew of different things. When I'm breaking this up, are there portions of it that I'm going to want to use in other projects later on? If there's a payroll component for this huge project, maybe I want to be able to use the payroll system to reuse that payroll system in a variety of other projects that I'm working on. So maybe I look at this and say, okay, well, maybe since I want to be able to reuse that payroll thing, it should be a module of its own or a subsystem of its own so that I can take that as a whole and incorporate it into other projects later. Right? So you might base your decomposition partially on which pieces do you want to be able to reuse as kind of a clump in other projects later. You also want to think about the logical division of your project based on what activities and what data is being processed within it. So thinking about for your tasks, where are you performing data input and error checking? Where are you storing data? Where are you transforming data? Where are you displaying data? Where does output get, or where does data output take place? So you might think about, okay, well, maybe I'm going to take this and decompose it in a way so that most of the input takes place together. Or maybe I'm going to do this so that there's, one clump that handles all of the storage. Maybe I'm going to take it so that there's one clump that handles all of the transformations. Maybe I'll have, one module or one subsystem that handles all of the output. So you might think of things like this and say, well, what am I going to group together? On the other hand, you might take it and say, well, the storage and the input you might want clumped together because they're tightly interrelated. Or again, there's all sorts of different ideas where you can look at the problem that you've got and say, well, these pieces belong together because. And as long as you're thinking through those options and as long as you're making a conscious choice and not just kind of stream of this is the first idea I came up with, splat, I'm going to turn it into code. As long as you're thinking through what your options are and going, if I do it this way, it's good because, I've got these things grouped together and I'm going to use them together lots of times, or I've got these things separated so that I can work on them independently. As long as you're thinking about the pros and cons of the decompositions that you pick and making a conscious choice, you're probably going to be better off in the long run. So one of the things that we're going to be thinking of in the longer term is getting a good balance of where your data processing takes place, where your storage takes place, and where transmission of data takes place. You want to decompose in a way that keeps things relatively organized. You don't want your developer to be in a position where to accomplish some specific task, they have to look at something and go, oh, part of this takes place over in this module, and part of it takes place over in that one, and part of it takes place in this other one over there. And so in order to accomplish their task, they wind up having to dive into the details of 3 or 4 or 5 different modules. If you've got a good decomposition, then hopefully an awful lot of the time, whatever the developer needs to work on for a specific task is going to be nicely localized in one specific component or one module or one subsystem. So we're trying to break things up in a way that keeps things logically cohesive, if you like, so that the things that we need to work on for any given task are somehow bundled together. Now, a lot of this becomes easier with experience. The first handful of times that you do different designs of any different scale, you wind up discovering, oh, okay, well, this doesn't work in the long run because, and often it's from our mistakes that we learn the most. We get the best experience when something just naturally flows together. We can remember it and go, oh, that's nice, that all worked out well. But often it's when something blows up further down the road that we realize, that wasn't a good way to do things. So we do try and learn from the mistakes of others and the advice of others, but often one of the best learning tools is actually making the mistake and having to fix it later. But the joys of experience. Load balancing is one of the interesting things that we'll often try and achieve. And again, this gets to be more of an issue as our programs scale up. As we get larger and larger programs spread across more and more systems, it becomes more important to think about these kind of ideas. Suppose I've got a system where, part of it's done on a web server someplace, and there's a database server that's doing some of the other work, and there's a bunch of mirrors of different things, and load balancing is, or we've got different gateways routing different parts of the problem to different servers, and then the client's got their machine that they're using to connect to these servers and make queries and ask for different things to be run, and we've got people using their phones and their browsers and whatnot. If a complex task is being carried out, we have to figure out which portions of the processing and what portions of storage are taking place on all of those different pieces. What belongs on the web server? What belongs in the database server? What belongs on the client machine? What processing is going to take place in each of those things? And depending on how we break it up, it might mean that to accomplish some given task, all of a sudden we put this huge processing load on one of those devices. We put a huge processing load on the database server, or a huge processing load on the client's machine, or a huge processing load on the database server. Or it might be the case that the actual the volume of data we need to transmit between different devices becomes huge. If I break it up this way, then it means that at this point in the program, I have to shove all of this data from, I don't know, the database server to the web server, or I have to push a whole bunch of data from the web server to the client machine. So we think about what kind of processing load we're putting on each different portion of the system based on the decomposition we've come up with, and we think about what kind of data transmission loads we're putting on each of these different portions. So our decompositions in the long term are going to start reflecting our knowledge of how much data we're forcing different parts of the system to store, how much data we're forcing different parts of the system to process, and how much data we're forcing different parts of the system to transmit between each other. And so these decompositions that we look at do become very important as we scale up the problems that we're working on, and as we scale up the amount of data that we're storing and processing. So these are all things that we'll come back and revisit again and again and again as we look at different algorithms, as we look at different data structures, and as we look at problems of different sizes and scales. All right, I will leave that there for now.